Sometimes 3D prints get these thin, wispy strands that don't look all that great. We call this problem stringing. Stringing is a minor 3D printing defect that can ruin the quality of your prints and make them unusable. I'm Stephen McCulloch from 3DQ, and today's video is the 10th out of 14 on our video series covering QuinlyVision, our AI 3D printer supervisor. Today I'll talk about what stringing is, how QuinlyVision detects stringing, why stringing happens, and how you can prevent it from happening on your 3D printer. So, what is stringing, and what does it look like? Well, strings are little strands of filament that connect two parts of a print, and you might hear it be called hairs or wisps or cobwebs, but they all mean the same thing. It means that there's material where material shouldn't be. The main problem is that stringing looks bad and it can be hard to remove. And sometimes if your print has a lot of stringing, then your print just becomes unusable. When QuinlyVision looks for stringing, it looks for a really thin line connecting two parts of a print. And it can differentiate between spaghetti and stringing because the lines of a string are really thin, like maybe only 1 or 2 pixels thin. So why does stringing happen in the first place? Well, stringing happens when material oozes out of the nozzle as the nozzle moves from one place to another. This can be because of a few reasons. Maybe it's the retraction settings are wrong, or maybe you're using the wrong temperature. And in some cases it can be that your material needs to be dried. And when you see stringing, you can sometimes also see other kinds of fails. So one common fail that's associated with stringing is over-extrusion, which I talked about in a previous video. But the main thing is that when over-extrusion happens, there's too much material coming out of the nozzle. So when the nozzle travels from one place to another, it brings some of that excess material along with it. Another kind of print fail associated with stringing is under-extrusion, and that's because under-extrusion happens when there's not enough material in the print, and since a string is material where there shouldn't be material, then there's going to be a gap at the end of the string, and that looks like under-extrusion. So what are some things you can do to prevent stringing from happening? Well, the first one is pretty simple. It's make sure that you have retraction enabled in your slicer. Now, just a really quick overview, retraction lifts the material out of the nozzle slightly so that there's nothing right at the tip of the nozzle. It brings it into the hot end a little bit so that nothing oozes out during travel moves. There are a couple settings you can adjust for this. The first one is retraction distance, and that's just how much the material gets retracted out of the nozzle, and retraction speed, which is how fast it gets retracted. If your 3D printer has a Bowden system, you're going to want a retraction distance of at least 3 millimeters, and if you're on a direct drive system, you can sometimes get away with maybe 0.5 to 1 millimeters of retraction. Retraction speed is a bit harder to calibrate. I tend to say that if you're using a larger nozzle, you should use a slower retraction speed. If you're using a smaller nozzle, you should use a faster retraction speed. But the best thing to do is just try all the different speeds and find the one that works best for you. Next thing to do is make sure that you're printing at a reasonable temperature, because if you print too hot, then stringing can happen. If you're printing a high quality part with kind of a slow print speed, then you don't need as much heat. So you can usually get away with a lower temperature than usual. So if you think incorrect temperature might be the cause of your stringing, then what I can suggest is dropping your temperatures by about 10 degrees and maybe slowing your print down slightly too. Now, some slicers have some additional settings that you can try that kind of reduce the effects of stringing by making the nozzle take a different path around the print. So one of those is combing, in which it tries to make the nozzle move through parts of the print that have already been printed, rather than crossing over open gaps. And the other print setting you can try is nozzle wipe, which just adds a little travel move right before retraction, and that can kind of clean the tip of the nozzle slightly, so the retraction happens cleaner. Finally, if you notice popping or crackling during your print, then that means your filament has moisture inside that's getting boiled essentially in the nozzle. This tends to only really be a problem for materials like nylon that absorb a lot of water. It can sometimes happen with PLA and stuff too, but the solution is just to dry your filament. So you can just get a filament dryer, or sometimes you can put your filament in an oven at a low temperature. I'd suggest following a guide for this. I wouldn't just randomly put your filament in your oven. So if you want to be able to detect 13 kinds of print fails as well as stringing, check out QuinlyVision AI. And you can actually do that by playing our new game, 3D Printle. This is a game where you can identify the 3D print fails in an image and compare your results to QuinlyVision AI. And that's all for today, so thanks for watching. Remember to drop a like on the video and subscribe to the channel if you haven't already, and I'll see you in the next one.